These weren't basic survival errors like getting lost or running out of food. These were sophisticated technical mistakes made by men who understood bushcraft principles but failed in the precise execution that wilderness survival demanded. They needed techniques that worked flawlessly under extreme conditions. They needed skills that could be executed perfectly when exhaustion, cold, and stress impaired their judgment. They needed knowledge that could prevent technical failures from becoming fatal disasters. Every detail mattered. One poorly tied knot, one incorrectly constructed trap, one failed tool modification, and an experienced bushcrafter could die from a technical error that should have been preventable. The men who survived decades in the wilderness had mastered not just survival concepts, but the precise technical execution that made those concepts work reliably. They understood that knowing what to do wasn't enough. You had to do it perfectly, every time. My name is Sam, and this is Wild America. 1. Incorrect bow drill technique. Execution. Bow drill fire starting failures killed experienced frontiersmen who understood the basic concept but made critical technical errors in execution that prevented successful ignition. Mountain man James Ohio Patty nearly died in the desert when his bow drill technique failed repeatedly due to incorrect spindle angle and inadequate downward pressure, despite having made fire successfully dozens of times before. The spindle angle errors proved fatal when frontiersmen held the drill at incorrect angles that prevented proper friction generation. The spindle had to be perfectly vertical to create optimal friction between the spindle and fireboard. Even slight angles reduced friction efficiency and could prevent coal formation entirely, leaving frontiersmen without fire capability in life-threatening situations. The pressure application mistakes occurred when frontiersmen applied incorrect downward pressure during the drilling process. Too little pressure failed to generate sufficient friction for coal formation. Too much pressure created excessive friction that wore out the spindle and fireboard without producing usable coals. The pressure had to be precisely calibrated for optimal coal production. The bow tension errors proved deadly when frontiersmen used incorrect string tension that prevented efficient drilling motion. Loose bowstrings slipped on the spindle, preventing consistent rotation. Overly tight strings created excessive friction that made drilling impossible or broke the bowstring during critical fire starting attempts. The tinder bundle construction failures occurred when frontiersmen created tinder bundles with incorrect material ratios or arrangement that prevented successful ignition from bow drill coals. The finest tinder had to be in the exact center, surrounded by progressively larger materials in specific proportions that would catch and hold the coal while allowing adequate airflow. The coal transfer technique errors proved fatal when frontiersmen successfully created coals but failed to transfer them to tinder bundles correctly. The coal had to be transferred at the exact moment of optimal heat, positioned precisely in the tinder bundle, and blown with the correct airflow pattern to achieve ignition. The wood selection mistakes occurred when frontiersmen chose wood species that seemed appropriate but lacked the specific characteristics needed for successful bow drill operation. The fireboard and spindle woods had to have compatible hardness ratios, optimal resin content, and appropriate grain structure for reliable coal production. The notch cutting precision errors proved deadly when frontiersmen cut collection notches in fireboards that were incorrectly sized or positioned. The notch had to be precisely angled and positioned to collect coal dust efficiently while allowing adequate airflow for coal formation. Incorrect notch geometry prevented successful fire starting. The timing coordination failures occurred when frontiersmen failed to coordinate the drilling speed, pressure application, and coal collection timing for optimal results. The entire bow drill process required precise timing coordination that could only be achieved through extensive practice and technical mastery. The environmental adaptation errors proved fatal when frontiersmen failed to modify their bow drill technique for different weather conditions, wood moisture content, or altitude variations. Each environmental condition required specific technical adjustments that many experienced frontiersmen failed to make correctly. Bow drill technique failures were particularly deadly because fire was essential for survival, and technical execution errors could leave experienced bushcrafters without ignition capability when their lives depended on it. 2. Faulty deadfall trap. Trigger mechanisms. Deadfall trap trigger failures killed experienced frontiersmen who understood trapping principles but made critical technical errors in trigger construction that prevented successful game capture. These technical failures meant starvation in situations where properly functioning traps could have provided essential protein for survival. The Paiute trigger construction errors proved fatal when frontiersmen built triggers with incorrect leverage ratios that were either too sensitive or too insensitive for target game species. The trigger stick length, support stick angle, and bait stick position had to be precisely calculated for the weight and behavior patterns of specific prey animals. The split stick trigger precision mistakes occurred when frontiersmen carved trigger notches that were incorrectly sized or angled, preventing reliable trigger function. The notches had to be cut to exact specifications that would hold the deadfall weight securely while releasing instantly when triggered by prey animals. The treadle trigger balance errors proved deadly when frontiersmen failed to achieve the precise balance point that would trigger reliably under prey animal weight while remaining stable under wind, weather, and environmental disturbances. The balance point calculation required understanding physics principles that many frontiersmen applied incorrectly. The Figure 4 trigger assembly mistakes occurred when frontiersmen assembled the 3-stick trigger system with incorrect angles or proportions that prevented reliable triggering. Each stick had to be cut to precise lengths and angles that would create a stable but sensitive trigger mechanism. The bait stick positioning errors proved fatal when frontiersmen positioned bait sticks at incorrect distances or angles that prevented prey animals from triggering the mechanism while feeding. The bait position had to be calculated based on the feeding behavior and body mechanics of target species. The weight calculation mistakes occurred when frontiersmen used deadfall weights that were inappropriate for target prey species. Insufficient weight failed to kill cleanly, while excessive weight made triggers too insensitive to activate reliably. Weight calculations had to account for prey size, trigger sensitivity, and killing effectiveness. The trigger sensitivity calibration errors proved deadly when frontiersmen set triggers that were either too sensitive, triggering from wind or weather, or too insensitive, failing to trigger when prey animals took bait. Sensitivity calibration required precise adjustment based on environmental conditions and prey behavior. The material selection mistakes occurred when frontiersmen used wood species or materials that lacked the strength, flexibility, or durability needed for reliable trigger function. Trigger materials had to have specific mechanical properties that would maintain function under stress and environmental exposure. The assembly precision errors proved fatal when frontiersmen assembled triggers with gaps, misalignments, or loose connections that prevented reliable operation. Every connection point had to be precisely fitted and secured to ensure consistent trigger function under field conditions. The maintenance and reset failures occurred when frontiersmen failed to maintain trigger mechanisms properly or reset triggered traps with the same precision as initial construction. Trigger maintenance required the same technical precision as initial construction to ensure continued reliability. Deadfall trap trigger failures were particularly deadly because they prevented protein procurement that was essential for long-term wilderness survival, leaving experienced trappers to starve despite having adequate trapping knowledge. 3. Improper knife and tool. Sharpening techniques. Tool sharpening failures killed experienced frontiersmen who understood the importance of sharp tools but made critical technical errors in sharpening techniques that rendered their tools ineffective or dangerous. Dull or improperly sharpened tools could make essential bushcraft tasks impossible and create dangerous situations that proved fatal. The angle consistency errors proved fatal when frontiersmen failed to maintain consistent sharpening angles that created optimal cutting edges. Each tool required specific sharpening angles, Knives needed different angles than axes, and different knife tasks required different edge geometries. Inconsistent angles created weak edges that failed under stress. The grit progression mistakes occurred when frontiersmen used incorrect sequences of sharpening stones or abrasives that failed to create properly finished cutting edges. Sharpening required progression from coarse to fine grits in specific sequences that removed scratches while creating sharp, durable edges. The pressure application errors proved deadly when frontiersmen applied incorrect pressure during sharpening that created uneven edges or damaged tool steel. Too much pressure created heat that damaged tool temper. Too little pressure failed to remove metal efficiently, creating sharpening sessions that took too long and wasted precious time. The stroke direction mistakes occurred when frontiersmen used incorrect sharpening strokes that created burrs, chips, or uneven edges. Each tool type required specific stroke patterns and directions that would create optimal edge geometry while avoiding damage to the cutting edge. The edge geometry failures proved fatal when frontiersmen created edge angles that were inappropriate for intended tool uses. Thin edges were sharp but fragile. Thick edges were durable but inefficient. The edge geometry had to be precisely matched to the tool's intended applications. The burr removal technique errors occurred when frontiersmen failed to remove metal burrs properly after sharpening, leaving tools with false edges that seemed sharp but failed under use. Burr removal required specific techniques that created true cutting edges without damaging the sharpened surface. The tool steel assessment mistakes proved deadly when frontiersmen failed to understand the metallurgy of their tools and used inappropriate sharpening techniques for different steel types. Hard steels required different sharpening approaches than soft steels, and improper techniques could damage tools permanently. The sharpening stone preparation errors occurred when frontiersmen failed to prepare sharpening stones properly, using dry stones that damaged tools or contaminated stones that created poor edge quality. Stone preparation was essential for effective sharpening results. The testing and verification failures proved fatal when frontiersmen failed to test sharpened tools properly before depending on them for critical tasks. Tool testing required specific techniques that verified edge sharpness, durability, and performance under actual working conditions. The field maintenance mistakes occurred when frontiersmen failed to maintain tool sharpness during extended wilderness expeditions, allowing tools to become dull when sharpening materials were unavailable. Field maintenance required planning and techniques that could maintain tool performance indefinitely. Tool sharpening failures were particularly deadly because dull tools made essential bushcraft tasks dangerous or impossible, creating cascading failures that could prove fatal in wilderness survival situations. 4. Incorrect natural cordage. Construction methods. Cordage construction failures killed experienced frontiersmen who understood the importance of strong rope but made critical technical errors in natural fiber processing and twisting techniques that created weak cordage that failed under load. Cordage failure could mean the loss of essential equipment, failed shelter construction, or inability to secure critical survival resources. The fiber preparation errors proved fatal when frontiersmen failed to process natural fibers correctly before cordage construction. Plant fibers had to be harvested at optimal times, processed to remove lignins and pectins, and prepared with specific techniques that maximized fiber strength and flexibility. The twist direction mistakes occurred when frontiersmen twisted fibers in incorrect directions that created weak cordage prone to unraveling under load. The individual fiber bundles had to be twisted in one direction while the final cordage was twisted in the opposite direction to create strong, stable rope. The tension consistency errors proved deadly when frontiersmen failed to maintain consistent tension during cordage construction, creating weak spots that would fail under stress. Every section of cordage had to be twisted with identical tension to ensure uniform strength throughout the rope length. The splice technique failures occurred when frontiersmen used incorrect splicing methods to join fiber sections, creating weak points that failed when the cordage was loaded. Splicing required specific overlap lengths and twisting techniques that maintained cordage strength across joints. The fiber length coordination mistakes proved fatal when frontiersmen failed to coordinate fiber lengths properly during construction, creating cordage with uneven strength characteristics. Fiber ends had to be staggered and overlapped with precise spacing to ensure consistent strength. The moisture content errors occurred when frontiersmen constructed cordage from fibers with incorrect moisture content that affected twisting characteristics and final strength. Fibers that were too dry became brittle and broke during construction. Fibers that were too wet failed to hold twist properly. The diameter consistency failures proved deadly when frontiersmen created cordage with uneven diameter that concentrated stress at thin sections. Cordage diameter had to be maintained consistently throughout the rope length to ensure uniform load distribution and maximum strength. The twist density calculation mistakes occurred when frontiersmen used incorrect twist rates that created either over-twisted cordage that was stiff and weak or under-twisted cordage that unraveled under load. Twist density had to be precisely calculated for optimal strength and flexibility. The load testing neglect proved fatal when frontiersmen failed to test cordage strength before using it for critical applications. Cordage testing required specific techniques that verified load capacity without damaging the rope before it was needed for survival tasks. The storage and preservation errors occurred when frontiersmen failed to store natural cordage properly, allowing it to rot, become infested with insects, or lose strength due to environmental exposure. Cordage preservation required specific techniques that maintained strength and flexibility over time. Natural cordage construction failures were particularly deadly because rope was essential for countless bushcraft applications, and cordage failure could create cascading problems that proved fatal in wilderness survival situations. 5. Faulty primitive shelter. Joint construction. Shelter joint failures killed experienced frontiersmen who understood shelter principles but made critical technical errors in joint construction that caused structural failures during severe weather when shelter integrity was essential for survival. Poor joint construction could turn adequate shelter designs into death traps during storms. The lashing technique errors proved fatal when frontiersmen used incorrect lashing patterns that failed to secure joints properly under structural loads. Each joint type required specific lashing patterns that distributed loads evenly while preventing slippage under stress. Incorrect lashing patterns concentrated stress and caused joint failure. The notch cutting precision mistakes occurred when frontiersmen cut joining notches that were incorrectly sized or angled, preventing proper load transfer between structural members. Notches had to be cut to exact specifications that would create tight, load-bearing connections without weakening the structural members. The load distribution errors proved deadly when frontiersmen failed to design joints that distributed structural loads properly, creating stress concentrations that caused catastrophic failures. Joint design had to account for wind loads, snow loads, and other forces that would stress the shelter structure. The wood selection mistakes occurred when frontiersmen used wood species that lacked the strength or flexibility needed for specific joint applications. Different joints required woods with different mechanical properties, and incorrect wood selection could cause joint failures under load. The moisture expansion planning failures proved fatal when frontiersmen failed to account for wood movement due to moisture changes, creating joints that loosened or failed as wood dried or swelled. Joint design had to accommodate wood movement while maintaining structural integrity. The connection redundancy neglect occurred when frontiersmen created joints with single points of failure that could cause catastrophic structural collapse. Critical joints required backup connections and redundant load paths that could maintain structural integrity if primary connections failed. The tool precision requirements proved deadly when frontiersmen attempted to cut precise joints with inadequate or improperly maintained tools. Joint cutting required sharp, properly sized tools that could create accurate cuts, essential for proper joint function. The assembly sequence errors occurred when frontiersmen assembled shelter structures in incorrect sequences that prevented proper joint construction or created assembly conflicts. Complex shelters required specific assembly sequences that allowed access for joint construction and proper load transfer. The stress concentration prevention mistakes proved fatal when frontiersmen created joint designs that concentrated stress at weak points in structural members. Joint design had to distribute loads smoothly to prevent stress concentrations that could cause catastrophic failures. The environmental protection failures occurred when frontiersmen failed to protect joints from weather exposure that could cause deterioration and failure over time. Joint protection required specific techniques that prevented water infiltration and wood decay while maintaining structural function. Shelter joint construction failures were particularly deadly because they occurred during severe weather when shelter integrity was essential for survival, turning adequate shelter designs into fatal exposure situations. 6. Incorrect fire, lay construction, and management. Fire, lay construction failures killed experienced frontiersmen who understood fire principles but made critical technical errors in fuel arrangement and fire management that prevented reliable ignition or sustained burning when fire was essential for survival. Poor fire lay construction could leave experienced bushcrafters without fire capability in life-threatening situations. The tinder nest construction errors proved fatal when frontiersmen built tinder nests with incorrect material ratios or arrangements that prevented successful ignition from sparks or coals. The finest tinder had to be in the exact center, surrounded by progressively larger materials in specific proportions that would catch and sustain initial ignition. The kindling size progression mistakes occurred when frontiersmen used incorrect kindling size progressions that created gaps in the fuel chain, preventing fire from growing from tinder to larger fuel. Kindling had to progress in specific size increments that would catch fire reliably from smaller materials while igniting larger fuel. The fuel wood preparation errors proved deadly when frontiersmen failed to prepare fuel wood correctly for optimal burning characteristics. Wood had to be split to appropriate sizes, dried to optimal moisture content, and arranged for maximum surface area exposure to ensure reliable ignition and sustained burning. The airflow management failures occurred when frontiersmen built fire lays that restricted airflow needed for proper combustion. Fire lays had to be constructed with specific gaps and arrangements that provided adequate oxygen while maintaining fuel contact for heat transfer. The heat transfer optimization mistakes proved fatal when frontiersmen arranged fuel in patterns that prevented efficient heat transfer between burning and unburned materials. Fuel arrangement had to optimize radiant and conductive heat transfer to ensure reliable fire propagation. The platform construction errors occurred when frontiersmen built fires on surfaces that conducted heat away from the fire or allowed moisture infiltration that prevented sustained burning. Fire platforms had to insulate the fire from ground moisture while reflecting heat back into the fuel. The wind direction consideration failures proved deadly when frontiersmen built fires without considering wind patterns that affected combustion air supply and heat distribution. Fire lay orientation had to account for wind direction to optimize airflow while preventing dangerous fire spread. The fuel density calculation mistakes occurred when frontiersmen used incorrect fuel densities that either smothered fires with too much fuel or starved fires with insufficient fuel. Fuel density had to be precisely calculated for optimal combustion efficiency and sustained burning. The ignition point positioning errors proved fatal when frontiersmen positioned ignition sources incorrectly within fire lays, preventing successful fire starting despite adequate materials and construction. Ignition sources had to be positioned at optimal locations for reliable fire propagation. The progression timing failures occurred when frontiersmen added larger fuel too quickly or too slowly, either smothering developing fires or allowing them to burn out before larger fuel could ignite. Fire progression required precise timing that could only be achieved through technical mastery. Fire lay construction failures were particularly deadly because fire was essential for warmth, cooking, water purification, and signaling, and fire failures could create multiple cascading survival problems simultaneously. 7. Improper plant identification and processing techniques. Plant identification and processing failures killed experienced frontiersmen who understood foraging principles but made critical technical errors in plant identification or processing that resulted in poisoning, nutritional deficiencies, or failed food procurement when wild plants were essential for survival. The morphological identification errors proved fatal when frontiersmen misidentified plants based on superficial similarities while missing critical distinguishing characteristics that separated edible plants from toxic lookalikes. Plant identification required understanding of detailed morphological features that could only be learned through extensive study and practice. The seasonal variation recognition failures occurred when frontiersmen failed to account for seasonal changes in plant appearance that affected identification accuracy. Many plants looked completely different during different growth stages, and seasonal identification required understanding of plant development cycles. The processing technique errors proved deadly when frontiersmen used incorrect processing methods that failed to remove toxins or make nutrients available from edible plants. Many edible plants required specific processing techniques to neutralize toxins or break down indigestible compounds. The dosage calculation mistakes occurred when frontiersmen consumed incorrect quantities of plants that were edible in small amounts but toxic in larger doses. Many wild plants had narrow safety margins that required precise dosage calculations based on body weight and plant potency. The preparation timing errors proved fatal when frontiersmen harvested or processed plants at incorrect times that affected toxin levels or nutritional content. Plant chemistry changed dramatically throughout growth cycles, and timing was critical for safe consumption. The combination interaction failures occurred when frontiersmen consumed plant combinations that created toxic interactions, despite individual plants being safe. Plant chemistry interactions could create dangerous compounds that weren't present in individual plants. The contamination prevention mistakes proved deadly when frontiersmen failed to prevent contamination during plant collection and processing. Environmental contamination, cross-contamination from toxic plants, and processing contamination could make safe plants dangerous. The preservation technique errors occurred when frontiersmen used incorrect preservation methods that failed to maintain plant safety and nutritional value during storage. Plant preservation required specific techniques that prevented spoilage while maintaining edibility. The quality assessment failures proved fatal when frontiersmen failed to recognize signs of plant deterioration, disease, or contamination that made otherwise safe plants dangerous for consumption. Quality assessment required understanding of plant pathology and contamination indicators. The emergency consumption protocols neglect occurred when frontiersmen consumed questionable plants during starvation situations without following safety protocols that could minimize poisoning risk. Emergency consumption required specific techniques that balanced starvation risks against poisoning risks. Plant identification and processing failures were particularly deadly because they could cause immediate poisoning or create nutritional deficiencies that weakened frontiersmen's ability to perform other essential survival tasks.